Hello and welcome to today's lesson. Today we're going to be talking about operations with rational numbers. So at the beginning, I'm going to look at how to multiply, divide, add, and subtract numbers that are positive and negative and the rules for that. And then we're going to move on to looking at how to do those operations as part of complex fractions. I've broken this video down into two parts. So this is part one. So before you work on this lesson in Study Island, make sure that you look at part two also. We want to make sure that you are using your time to the best of your ability. So go ahead and make sure that you are taking notes during this lesson. And if I ever go too fast, just pause and rewind and you can get caught back up. You can even pause at the beginning of a question, work the problem out yourself, and then watch how I do the problem and compare your work with my work, and you can be able to see where it is that you're doing really well and areas that you might still need to study and work on. I'm so glad that you are joining us today, and let's go ahead and take some notes. The first thing you're going to copy down in your notes for this lesson is how to add and subtract integers. So what to do when you have numbers that are both positive, both negative, or one's negative and one's positive and you're adding and subtracting them. So if they have the same signs and you're adding them, so you have two negative numbers or two positive numbers, ignore the signs and then you just add the numbers and then you just keep the signs that they originally had. So if they were both negative at the beginning, your answer is negative. If they were both positive in the beginning, the answer is going to be positive. Now, if you have different signs, so one number is negative and one number is positive, and you're adding them, you're still going to ignore the signs, but this time, because they're different signs, you're going to find the difference. You're going to subtract. Different signs, find the difference. And then you look and see which one of those numbers was bigger. And then if that number was positive, your answer is positive. If that number was negative, your answer is negative. Subtraction is the same regardless if you have two positive, two negative, or one of each. Your subtraction, you're always going to keep the same number the same, this first number the same, so that one stays. And then you change the sign of the second number, and you change the subtraction to the addition rule. So some people call that the stay, change, change. And then you follow the appropriate addition rule up here. You're also going to need to know how to multiply and divide integers, so numbers that are positive and negative. So if you have the same signs when you're multiplying or dividing, so two positive or two negative, your answer is always going to be positive. Remember, two negatives make a positive. And you can remember that by these smiley faces. Two positives, the nose is positive, your answer is positive. Two negatives, the nose is positive, your answer is positive. If you have different signs, your answer is going to be negative. So if you have a negative and a positive number, no matter which one's first or bigger, that nose is negative, it's always going to be a negative answer. So if you have one negative, your answer stays negative. So remember, if you have a calculator, you're not allowed to be using the positive or negative button until you're in 8th grade. If you have a calculator that's able to do that. So here we have a division problem, and I have opposite signs, so that means my answer is going to be negative. So I can write that in right away. And then I just look, 6 divided by 2 is 3. So 6 divided by negative 2 is going to be negative 3. For my next problem, I'm multiplying two negative numbers. So they have the same sign. Two negatives make a positive. So my answer is going to be positive. But we don't write the positive symbol, but I'm just writing it up above so I don't forget. Now you can use your calculator to do 36 times 4, or you can write it out and do it longhand. 6 times 4 is 24. Write down the 4, carry the 2. 3 times 4 is 12, plus the 2 is 14. So that means negative 36 times negative 4 is going to be positive 144. here I'm multiplying a negative and a positive number. So I'm going to have a negative answer. Different signs, one negative is a negative answer when you're multiplying and dividing. So I'm going to go ahead and write the negative out. You can use your calculator to multiply those two numbers, or you can write the problem vertically and work it out longhand. If you work it out longhand, I would just use the calculator to check yourself so that you have the ability to know that you got the problem right. So here, 5 times 3 is 15. Carry the 1. 2 times 3 is 6, plus the 7, plus the 1 is 7. You can scratch that out. And then you do the second 3. 3 times 5 is 15. Carry the 1. 3 times 2 is 6, plus the 1 again is 7. And then you add these. So it's going to be 5, and then 12, and 8. So negative 825 is going to be your final answer. Next, we're going to be looking at how to do operations with fractions. So if you're adding and subtracting a fraction with the same or common denominator, you just add the numerators and the denominator stays the same. If the denominator is different, then you're going to have to find that common denominator, and then you can add the numerators and the denominator stays the same. If you're multiplying fractions, you multiply across. So you're going to multiply the numerators, you're going to multiply the denominators, and then you simplify. If you're dividing fractions, then you're going to change the division to a multiplication, and then you're going to flip the second fraction. Then you multiply the numerators and multiply the denominators. So make sure you have those all down in your notes. If I went too fast, just make sure you pause and rewatch what you need to. The last bit of notes before we start in on the second type of problems is you're going to need to know how to convert a decimal to a fraction. To do that, I'm going to look at the place value of the last digit to the right of the decimal point. So here that's going to be 5, and that place value is the hundredths column. So that means you put 100 in your denominator. The second step is to take that entire number and remove the decimal and make that number the numerator. And then you reduce the fraction to lowest terms. Now let's look at some problems. So here I have a fraction being added to, this is called a complex fraction, when you have a fraction over a fraction. But what this means is that you are dividing the top fraction by the bottom fraction. And so order of operations, you always do this division first. So I'm going to go ahead and rewrite that problem, just showing that division horizontally instead of vertically. And that's what that looks like. So we do division before addition. So remember that when you're dividing fractions, it becomes multiplication, and you have to invert or flip the second fraction. And everything else is going to stay the same. And I'm going to go ahead and do that multiplication. So I'm looking at multiplying these two fractions. Now you can use the calculator or work it out longhand to multiply 24 times 21 and 35 times 8. But then you're going to have to simplify some really big numbers, and that can take some time. So what I like to do beforehand to make my number smaller is to see if I can simplify any numerator number with any denominator number. So I can see that I can divide an 8 out of 24 and 8. So I'm going to go ahead and do that. 24 divided by 8 is 3, and 8 divided by 8 is 1. And then I can also see that 35 and 21, I can divide a 7 out of. So I'm going to go ahead and do that. 21 divided by 7 is 3, and 35 divided by 7 is 5. And then I'm going to go ahead and multiply the numerators with these smaller numbers and the denominators with these smaller numbers. So 3 times 3 is 9. And 5 times 1 is 5. And that's a fraction that I don't have to simplify. So then I still have to add this first fraction to that. So I notice that the denominators are different. So I'm going to have to find a common denominator. 5, if I multiply that by 3, will give me 15. So I'm going to go ahead and multiply the top and the bottom of this fraction both by 3 so that I can have a common denominator. 9 times 3 is 27. 5 times 3 is that 15. And this first fraction stays the same because it already has a denominator of 15. And then I just add the numerators. 4 plus 27 is 31 over 15. Since the denominators stay the same when you're adding. And then I look to see if the answers I'm given leave the fraction improper or if I need to simplify further. And C matches the answer that I got, 31 over 15, so C is going to be my final answer. Here we have two complex fractions being added together. And a complex fraction is just a fraction divided by a fraction. So I'm going to rewrite those complex fractions side by side with a division symbol. So that's going to be 24 over 7 divided by 8 plus 5 divided by 14 over 15. And now, order of operations tells me I do division before addition. So when I'm dividing with fractions, I have to change this to multiplication and flip the second one. So remember when you have whole numbers, you can put a 1 underneath them. So I'm going to go ahead and do that to make it look like a fraction to help me out with my rules. So the first fraction stays the same, changes to multiplication, and I flip the second one. The first fraction stays the same, change it to multiplication, and I flip the second one. And I still have addition here in the middle. Now, to make it so that I'm multiplying smaller numbers and I don't have to simplify as much at the end, I'm going to look at, this multiplication problem right here. Is there any numerators that I can reduce with denominators? You don't have to do it this way. You could just multiply across and reduce at the end. I just find that this is easier and I have to do less guess and check. Either way will get you the correct answer though. So here I see 24 and 8. I can divide an 8 out of both of them. So 24 divided by 8 is 3, and 8 divided by 8 is 1. And so that's going to make it so that I'm just taking 3 times 1 in the top, which is 3, and 7 times 1 in the bottom, which is 7. And then I'm going to go over here and look at my second multiplication problem. 5 and 15 on top, and 1 and 14 on the bottom. There's nothing that I can reduce with any of those pairs, so I just have to multiply across. 5 times 15 is 75. And 1 times 14 is 14. Now, I just have to finish by adding these two fractions. When you add fractions, you need common denominators. So here I have a 7 and a 14. And the multiples that they have in common is 14. So I'm going to take 7 times 2 to get 14. And then whatever I do to the denominator, I also have to do to the numerator to keep them equivalent. So 3 times 2 is 6. And 7 times 2 is that 14 I wanted to get. And I'm going to add that to 75 over 14. I don't need to change that one because there's already a 14 in the denominator. And then when you're adding fractions, you just add the tops. So 6 plus 75 is 81. And the denominator stays the same, so it's going to be 14. So my answer here is 81 over 14. And I look at my answers, and I see I don't need to reduce that any further. I can leave it improper because it matches C. So that's going to make C my final answer. Now in this problem, I have one complex fraction. The complex fraction, though, has decimals and fractions in it, so I'm going to need to first change these decimals into fractions. Now remember, back to our notes, it said to look at the last place value after the decimal, which here's the 5, and that's in the hundredths place value. So that means I'm going to make my denominator for that fraction 100. And then my second step is to take this entire number and drop the decimal and place it in the numerator. And I'm not going to reduce that right now, just to see how the problem goes, if I need to or not. And so I'm still going to have that times 10/3 all over, and then I have another decimal I have to do the same thing with. The last decimal place value here is in the tenths column. So that means my denominator is going to be 10, and I'm going to take that entire number, 0.6, and drop the decimal, and that's going to be my numerator. So I'm going to have a 6 as my numerator. Now, when you have a complex fraction, you want to do any operations that you have in the top of the fraction or the bottom of the fraction first. It's a type of grouping that the P stands for in Please Excuse My Dear Aunt Sally or PEMDAS, in order of operations. So I need to do that first. And so I'm going to go ahead and simplify this first fraction by dividing out of 5 out of both the top and the bottom, just to make it a little smaller and easier to work with. So 135 divided by 5 is 27, and then 100 divided by 5 is 20. And so I can keep looking to see if I can cancel any more between any of these numerators up here, multiplication problem, and any of the denominators. I'm going to go ahead and rewrite it real quick so it doesn't get too sloppy. So right away I can see I can divide out a 10 from 20 and 10. 20 divided by 10 is 2, and 10 divided by 10 is 1. I can also divide a 3 from the 27 and the 3. 27 divided by 3 is 9, and 3 divided by 3 is 1. So that gives me a lot of small numbers to work with. Like I said, you could multiply through first and then reduce. I just find that this is easier. So 9 times 1 is 9. And 2 times 1 is 2. And then I still have that all over 6 over 10. So now I can rewrite this complex fraction horizontally. And so that's going to be 9/2 divided by 6/10. And so I'm just dividing two fractions. And when you're dividing two fractions, the rule is that the first fraction stays the same, change it to multiplication, and flip the second fraction. And so now I'm just multiplying fractions. So I'm going to look first to see if I can reduce anything between the numerators and the denominators. And I see that 2 and 10, I can divide out a 2. So 2 divided by 2 is 1. 10 divided by 2 is 5. And then I also see between the 9 and the 6, I can divide out a 3. 9 divided by 3 is 3, and 6 divided by 3 is 2. Then I just multiply across. 3 times 5 is 15. 1 times 2 is 2. And I can't reduce that any further. And I can leave it improper because it matches D, my final answer. Thank you for joining us today, and I hope you learned something new.